let's address the position about the coding aspect, right? So number one, uh, the genetic code has syntax, semantics, and pragmatics. The and since you're a coder, you know exactly what I'm talking about. And there is a compiler. There is a executable functions, right? There are also if then and else statements and outcomes. Beyond, and just as to put this in context, there are multiple programming languages that have been developed which directly translate into genetic functions. I think there's like 6 or 7 of them now, and there's a massive push, just like uh, not that long ago in the coding realm, where the fights between Python, Ruby on Rails, all those different ones, which one's going to have the most popularity and most functions, right? And then Angular, JS, and Node, and all those different pieces, which one's going to be the most popular? But the exact same thing is occurring in bioinformatics and genetics, because they've realized, holy crap, this is qualifies as Turing complete, and we have been able to create our own languages which can be compiled and executed into biological functions. And all of the logic rules exist, the logic gates for all of the programming. So in the context of existence of life, if every form of life that we see has a fully executable programming language, syntax, semantics, and pragmatics, and all different variables that are required for it, and we observe the abstraction of the meaning of the code base is being translated. Since you're a coder, do you ever think that ASIC and anything else would be able to be translated into binary from JS and vice versa without an intelligent agent first having applied the abstraction to the meaning of those code bases? Nucleic acid can spontaneously form without purpose, such as a polyidenose something other, forming by physiochemical law on a Montreux-Morlierite clay template surface. But the latter is a classic example of all the switches being set the same way when law is involved. A polyodisonine is a nucleic acid, but it can't program anything. It can't relay any information because all of the four-way switches have been set the same way by law. What so many fail to realize is that RNA and DNA are nothing but ordinary physical molecules that have the potential of being used for information retention only through selection of each nucleotide. It is the sequencing of particular nitrogen-based selections that accounts for any information retention in a nucleic acid molecule, not the largely inert DNA itself. Prescriptive information is not physiodynamic. It is formal, though it can be instantiated into a physical medium using dynamically inert configurable switches. The number one, that just the relevance of RNA being able to form from a purely chemical perspective is irrelevant to the syntax, semantics, and pragmatics that have to be derived from the non-random structure of the sequences in it, and the development of a syntax that can be translated and executed through semantics and pragmatics. And that is abstract. Again, I keep using this term. That is abstract information that does not have physical form, because it's two completely separate things. And it's like saying that the meaning of the JavaScript you write in English and its translation into binary, that somehow those two are the exact same thing without the translation protocols. And moreover, how do you conclude that even though they can be interpreted to mean the same thing by a computer that has the appropriate elements, or a human reading it has the intellect, how do you say those things happened without the intelligent agent and just randomly occurred?